So what they want us to do here is write a balanced equation. Now they're trying to help us because they're telling us we've got nitrogen and hydrogen. So let's put those two down first. And hydrogen. Now remember, nitrogen and hydrogen are both diatomic, so we need N2H2. Also they're telling us it's reversible, so we need the reversible symbol in the middle. And then they're telling us that the formula for ammonia is NH3. What we need to do then is just balance, because again, helping us out, balance the equation. So this side, we've got two N's and two H's. This side, we've got one N and three H's. So I'm going to concentrate on the hydrogens for a moment. How do I get 2 and 3 to become the same number? Well, they can both become 6. So what I do to get that to 6 is multiply that by 2. That gives me 6. I'm going to multiply this by 3 to give me 6. And that also changes my nitrogens to 2. So we've actually balanced the equation. Marks wise, to do this, you're going to get 1 mark for balancing it. So 1 mark for putting the 2 and the 3 in, a mark for getting the symbol in, and then a mark for the formulas being correct on this side of the equation. So 3 marks. Okay, so conditions for the Haber process. Again, a little bit of core knowledge. You know the temperature is 450 and the atmosphere is 200. If you don't know that, then go and learn it because you need to know those conditions. Okay, the purpose of the iron is to act as a catalyst. Remember, catalysts make reactions increase, go more quickly. And then this one, the reaction between nitrogen and hydrogen making ammonia is dynamic. The reaction gives out heat. So what this means is going in that direction is exothermic. And that means it's going to make things feel hotter, giving out the heat. Explain how the position of the equilibrium changes if the temperature is decreased. So what we have to do here is remember that if we try and decrease the temperature, then equilibrium law, so you may know that as Le Chatelier's principle, equilibrium law says it will do the opposite. And by doing the opposite, that means it's going to want to increase the temperature. So how can this reaction increase the temperature? What it can do is it's going to move to the right because the right makes it hotter. So then we say that the equilibrium will move to the right. And the reason why, because it is exothermic in this direction. Okay, marks wise, you're going to get 1 for explaining that that's because it's exothermic in the direction, and the other because it's going to do the opposite of what it's been forced to do. Okay, carrying on. Compound A is a brown gas, compound B is colourless gas. 2 molecules combine with that. At room temperature, equilibrium mixture is pale brown. Devise an experiment to show how absorption is affected by temperature. Okay, so let's just put a little bit of information here into an equation. So we've got A and B, and it says 2 molecules of A form B. This is a brown colour, and this is colourless. Okay, and it says so how it's going to change due to temperature. So what you would do here is you're going to heat up tube and see what happens to the colour changes. Okay, So the first thing to do is probably the best way to heat this tube up. Heat the tube by placing it in hot water. So you want to heat it with a Bunsen because that's going to affect the pressure inside the tube. It's going to warm it gently. It's going to heat it in hot water. And what you would do here is you would observe the color change. Okay. And then what you would do is you would then place the tube in a beaker of ice. That's going to cool it down. And again, we would observe the color change. How does it change color? Marks wise, you get a mark for saying put it in a hot condition, a mark for saying put it in a cold condition, and then a mark for recognizing that you need to observe the color changes.